All right. Well, thanks everybody for coming to COM321. My name is Brian Huff, and this is your Developers Security Survival Guide. But yeah, thanks for coming. So I want to paint a picture for you. This was pretty ordinary Friday, and I tried to log into AWS, as I'm sure you all have before, and I get this message, and it says, I can't sign in. And I try about, 3, 4th, 5th password. Nothing is allowing me to log in. I reach out to my team, and no one else can seem to log in either. It's pretty weird, and some of our production workloads actually were down, and services were pretty disrupted. So we check the dev inbox. We find out that we got an email from AWS Incident Response that said that there was some unusual behavior in our AWS account. So then you start thinking, couldn't have been us. Now we start thinking that there was probably an incident. Something bad had happened, and you start feeling, oh no. So we're going to be talking about that today. Sometimes things go really great, but sometimes things don't. And how do you get out of those types of situations? So my name is Brian Huff. I am an AWS DevTools hero. I was formerly an AWS community builder, for anyone that might be a community builder or hero here. So I actually got into development from a non-technical background. And I just loved building. I loved creating things. And that's sort of how I just ended up here. And then I found myself needing to do a lot more security things. So that's kind of where I had to become a security engineer, literally building the rocket ship as I'm flying it, in a sense. So in our talk today, we're going to be going through a DevOps security primer. If any of y'all are interested in DevSecOps and what that actually means, this will be a great intro for you. Then we're going to be going into really incident response. So what I shared with you earlier, how do you deal with a situation like that? Threat mitigation, how do you deal with these types of problems in a forward-looking direction? And then architecting, how can we build patterns for really good development moving forward? So let's start with the primer. And I want to get a show of hands here. How many people have had to change their password for an account? Let's see some hands. OK, cool, yeah. We all have, right? Two-factor authentication. How many people have had to do that? Right? OK, yeah, a lot of hands. How many people use password managers or one-time passwords? OK, yep. And VPNs, intranets. We like those. Yep. All right, cool. So why do we do all of these things, right? There's these best practices, but everybody kind of does the same thing. And there's these 7 buckets of good security that I feel like everybody does. These are the types of things that we all do. We don't really think twice about it, or we're kind of told to do it or to abide by these standards. But there's a good reason for that. And if you're a software engineer, or I like to think that I build applications, but I then talk to my security colleagues, and they tell me what I can't do. Or they'll try to hack a build that I created or something like that. So I like to think about it as engineers ship applications and security engineers ship access. But today, we're going to be thinking about how do we bring a union between these two elements and bring them together. So to start this off, I sort of think about a triangle where we want to build something secure, we want to build it quickly, and we want to have a reliable system that will work for our users and our developers. So to get started in DevSecOps, I really think it starts at the IAM level. So those are the JSON documents that you write, tells services what they can and can't do, tells applications or deployer roles what they can create within CloudFormation or something like that. So I do think this is a really great starting point if you are interested in DevSecOps and want to really dive into that. A great example could be you build an application, you deploy it, and you have a static build. You put that in S3, but you don't want that open to the public. So you'll have a CloudFront distribution that will only have access to that S3 bucket. And if you're ever interested in diving into this, I know AI is kind of like the hot topic for, I'm sure you all, but I actually do recommend using Amazon Q. You can just plug it into VS Code. And I was actually writing an S3 bucket policy, and Amazon Q just helped me build that out really quickly and also be a double checker for what I was building. So I definitely think it starts at this level. Now, this talk isn't really going to focus on OWASP, but I do think it's important to ground when we use these managed services. AWS, Auth0, Okta, a lot of these companies have to deal with these types of security vulnerabilities. And if that's not overwhelming enough, there's also a top 10 for mobile. Now, when we use managed services, the company is abstracting a lot of this from us. So again, we're not talking about OWASP today, but just to keep that in the back of your mind that these are things that are important to address. So now we start thinking about least privilege access. So between these two policies, you see one that they're basically the same, but the action has a star. This one has S3 get object. So they basically will do the same thing, but the one on the right allows deletes, allows puts, allows a lot of other S3 actions, but the one on the left just allows for a get. This is very simple, but it becomes very important because when I was developing, I thought, I just want to give access to all the actions and give it to this resource and go. But you actually shouldn't do that. You really need to know what the services need at the least amount possible. And that's where, as a developer, you start thinking about, I really want to make my software work. I want to give access. but you should actually spend a lot more time thinking about who doesn't have access. That's going to be a lot more important for your users, for your security, and your overall security posture. So yeah, it will take more time to do the permissive things, but it's a lot more critical for your application. So, and again, this is just a solution architecture diagram. I have code for this at the end of the talk, so you'll be able to QR code that. So you don't have to focus on this too much right now, but I'll be referring to this throughout my talk. And this is a pretty simple AWS organization solution architecture diagram. So if I had showed this to you, or you showed this in a room with your colleagues, you'd say, that looks like a pretty legitimate solution architecture diagram. Everything looks good, right? It seems like everything's fine. But you really should think about it. Is everything fine? And that's something that we're talking about today. So when you do a threat modeling exercise, that's where you're going to start digging into what are the security vulnerabilities that could pop up. So again, this is just a small fraction of things that could go wrong, but does your application have a content security policy? Does that protect against cross-site scripts? Does it protect against DDoS? Do you have a web application firewall? Your AWS keys or your user pool? If someone got privileged access to do something, do you have a takedown procedure for that elevated access? There are a lot of things that could go wrong when you're building. So let's say you bring on, a CISO or a security advisor, and then they, tell your engineers you do all the right things. So now you have all these check marks between before we had a lot of X's, now we have check marks. You think everything's right, as we all should think. But that's still where we still will need technology. We'll still need ways to check if we actually did it correctly. So if you think that you've done everything correctly, you might not have. And what to do in a security event is something that we should talk about. No one wants to talk about incidents, but they do happen. And I think it's a lot better to have those conversations here so that when you go out to your companies, you don't have these types of things and wonder, what should I do? So the 4 top questions that I think you should immediately ask when you are in an incident is who, what, where, and why. So who has access to what services or systems where, in or out of the cloud? Why? So it's who, what, where, and why. And very simple, but I'll show you why this is really important to get right and to know as quickly as possible. So this is an incident response resolution checklist that I've worked on with clients. And again, you don't have to write all this down. We're going to be going through these steps one by one. But this is how I like to think about a takedown procedure if you are in an incident. So the first step that you're going to want to do is use CloudTrail. So this is basically your API for everything across your AWS organization. So and you'll see a diagram of this later, but everything goes into app config, and then it goes into CloudTrail, and then you'll be able to then start tracking all of the things that are happening. So on the right there, that's the resource that was used. That is basically the action or the event, what happened. And then that's the user. So it'll tell you basically who did what, where in your AWS account. Now, you should really learn how AWS works. Because when you go in the console, you use CLI. We do things in AWS, but how do we know what is actually happening? So if we can start learning the event names and the types, it become really helpful. One very important thing to think about is when you have the create role, you really need to know who's creating an IAM role, because if you had an intrusion, somebody created a role that had elevated access to certain services, you want to be really careful that you know who did that. Because if they have keys that then have access to admin, now they can do basically anything in your account. So you have to be really careful of that. So next step, restricting access to IAM within AWS. So you'll see here that this has the activity of the users that are in your account. So you might have an intrusion where somebody creates a user, they created an access key, and now they can do maybe certain things in your AWS account. So you want to be really careful and know who are these users that are in your account. And if you see something that looks suspicious, you really need to stop that right away. So a way to get started thinking about this, I like to think about these as entity resource action graphs. So you have an entity or a person or some sort of role. You want to check the resources that they targeted. You want to check the actions that were taken by that user, and then their mitigation status. So this is a helpful, and you could even do this in a shared document or some sort of way that you can share this quickly amongst your team as it evolves. But you want to really have visibility in this, because as you go through mitigation, you really need to know, they had access to this resource, they don't anymore, but they had access to this database, or they had access to this bucket, and basically this is what we think that they did. So this will be really helpful in also documenting what you did and how they got there. Now, the next step, we'll be using Security Hub. So it's a really great and helpful tool for scanning your organization. It also can scan your CloudFormation template, resources, and it gives you a lot of visibility onto vulnerabilities across your account. So it'll basically take the findings, resource, and account, and then it'll give a severity rating. So I think that is immensely helpful, because if you really want to learn about DevSecOps, this is it. This is by the experts at AWS, and you can also abide by certain standards like NIST or Amazon standards for security. But it becomes really helpful to know that this is a critical, this is a high, so you know what to prioritize, because everything is important, but certain things are more important than others. So then the findings become actions, and that's where you use AWS to then help you manage these types of situations. So restricting access to the AWS organization, this is kind of on the way out. We then want to take our entity resource action graph. We want to then enforce two-factor authentication. We want to make sure that we are having conversations amongst our team. And we want to make sure that we're auditing CloudTrail and all these API calls to make sure that everything that is happening within AWS makes sense. Then on the application or the software or system side, we definitely want to check any logins or identity providers. We want to check buckets. We also want to check databases, make sure that those are locked down, that those weren't made public or something like that. Tracking suspicious API calls with CloudWatch, really great for logging, and also monitoring CloudTrail events. So we're going like breakneck speed. This is a lot of things, but this is really important to work really quickly, and that's kind of the pace of this talk, right? We have to do this very, very fast and know a lot. Okay. So take a little bit of a breather. What do we do if we're not under attack? So we can breathe, we can relax a little bit, but we do want to plan ahead and be proactive, because an attack might happen tomorrow, it might happen in a week, it might happen in a month, it might never happen. But you do want to prepare for a worst case scenario situation, and there's things that you can do to prevent that. So now this is talking about threat mitigation. So this is a checklist. We're going to be going through all these steps, so don't feel like you need to write all this down right now. We'll go through these steps one by one. But this is how I like to think about working with clients, where you are architecting for the future problems that could happen, or not. Hopefully not, but we should still think about it. So we already talked about Security Hub, but pretty simply, you'll have AWS accounts. You probably have one. You're creating resources. Then you want to create another AWS account. You want to basically put app config in there. All the resources are going to flow into that filter, and then that will go into Security Hub and tell you basically what's happening across your whole organization. And I see some head nods, so yeah, I'm sure you all might have heard or seen Security Hub. Just a quick thing about this will take anywhere from 11 hours to 24 hours for a very big organization. So I actually set this up before I went out to a conference and to a concert, and then I came back. So it was still chugging away while I was coming back, but it will take a long time if you have a lot of resources and a lot of CloudFormation templates. So just keep that in mind, that it'll start analyzing resources. You'll be able to see it instantly, but for the whole organization, it will take some time. So now when we set up logging with CloudWatch, Lambda comes pre-baked with a way to log into CloudWatch, but that policy is actually helpful to think about, because when you start logging in CloudWatch, you'll have resources, and then those will flow into dashboards and into logs that then you can dig into and look at. Basically, if you're trying to track suspicious IP addresses, if you're trying to track how many people are targeting a specific resource, that becomes very helpful for logging. And also, you could do S3 bucket logging. That's also something that doesn't come by default with S3. So just keep that in mind if there's a bucket that you do want to track how many pings it's getting. You'll have to set up that manually, but also very important. So when I like to think about building, a big realization that I had was using infrastructure as code to then deploy my applications. So I told you that I got into the development as a non-technical engineer, non-technical background. So I started abiding by infrastructure as code. So there's SST, there's serverless framework, there's SAM, there's Amplify. I've coded, at the end of this talk, that I used SST, which abstracts CDK, for building a Next.js application with App Router. That's kind of my default stack. But it's important to think about these types of ways to build, because there's patterns that you can replicate. You don't have to think about it every time. It's a repeatable process. Now, when we think about blocking access to private data, you'll have users. They might log into something like Cognito. Now, let's say that we need to get access to an S3 bucket. So, once they get a jot back, they'll go to Lambda, and then the Lambda will hit S3. But we don't want to have S3 public. So that's why we have block all public access on by default. So how do we get that data out of S3 and into our users' hands? So pre-assigned URLs, very, very, very simple implementation. This is a Python script that is for that. But pre-assigned URLs are really helpful because it creates this time-limited authentication token to the resource or to the file that can then go back to the user, and then it'll expire after a certain period of time. So again, a really helpful strategy just to make sure that you're not giving public access to all these files for any user at all. You can really lock down who has access. And a great pattern also, if anyone here is using RDS, You can use an IAM authorizer to request a token for a user. That token can then be issued to RDS, and then you'll be able to then allow that data to come back. So a really great way to have passwordless RDS uses for your users, but not needing to hard code those specific elements into your files or your scripts, those types of things. All right, so short-term credentials by default. We kind of talked about IAM a lot in this talk, but it's really easy to just create an IAM permission, create a role, and then create a user. We don't want to do that. The reason we don't want to do that is because anybody that has access to those types of roles will be able to do anything with those permissions for forever as long as the key lives. So a much easier way if you want to give users specifically access maybe to Amazon Bedrock if you're interested with experimenting with any of those AI or ML services. If you're not AI or ML'd out, you might want to do that. But it's much easier to just give time-limited access to a service like Bedrock or a specific model with permission under a management account. And then you can basically just take these, you can copy and paste it into your terminal. You can add this to your config credentials file on your computer. But we like that. It makes it really easy to just give access for a certain period of time, and you manage that as an organization from the top down. The secrets manager, you can store your secrets in a centralized location, give access to that for specific applications for users through IAM. And then it looks like that. And then you're able to then literally copy and paste code from the AWS console into your application, into your script, anything that you need that. So it's just really helpful to think about those short-term credentials. Secrets Manager also can rotate keys for you automatically, which is a really great way to build. You can also use the date greater than and date less than condition for IAM policies. Lesser known abstract of IAM, but you can also give access maybe for a month for a specific user of your account or a service or something like that. So then we start thinking about CI/CD pipelines with automation. So if you're using CDK or SST, which abstract CDK, but it's still using CDK. So when users commit to GitHub or something like that, you'll be setting maybe like a dev stage. So when you do appsynth, that will take resources, put that into a stage called dev. And then now if you want to do that on prod, you'll do appsynth. Same resources, same stack, but now they have different names for the same services. So your developers can actually use the dev branch, and then your users can use the prod branch. And when you like everything on dev or review or any of these other stages you make, then you could just push that up to prod and promote it. And then now your users will actually have access to that. And again, if you're not AI or ML'd out, I played around with Code Guru. It's a really great resource for security and for auditing. Basically, it's kind of like a security scan for your repository. So users will commit. This YAML file already exists in the repo that I'll show the QR code in a bit. But you just commit. The YAML file will iterate over all the lines of your code. It'll go to IAM, it'll go to Code Guru, and then you'll get something that looks like this. So low, medium, high, or critical. It'll tell you the security vulnerabilities of your code automatically in a script. And then maybe if you don't have a certain number of vulnerabilities, you can promote that to then go to CDK and then update CloudFormation. But we're using AI and ML to empower our security. So again, you all are doing all the right things, but just having that in the back of your mind, in your toolkit, is just a really great way to just program in very smart infrastructure as code into your development. And then if you have like more complicated code, you could also use Lambda with Bedrock. So you can just have that also in your actions as well. So last step, I promise. We're going through a lot of stuff, so thanks for bearing with me. So if we want to protect our applications against DDoS or cross-site scripts, what do? So a user, we don't exactly know if they're a good user or they're a malicious user. So we do need to think about any person that could be accessing our application. What are their motives? We don't necessarily know. So when they hit your hosted zone in Route 53, we want to hit them with Shield. So that will protect against DDoS. So if you had like a bot that was trying to like take down your application or your system, that will protect against that. We'll add another layer in there with WAF, and those also have managed roles where that could have certain injection pattern, threat mitigations, certain types of ways that a user could try to penetrate your application or get access to something. So you'd want to make sure that you have those layers in place way before you're accessing the content distribution network and then before they get access to that hosted code. So this is just, again, a way where you can take many different layers of security into your application. And also just a quick note that internal tools are not internal unless they're on your company's VPN and SSO. So you have a lot of public resources that might be generated. You want to make sure that it's really locked down if it's an internal tool, right? So that will take 96 hours of turmoil, hopefully into a calm Friday afternoon. And that's what I hope from this talk will be helpful for you so you can start thinking about security and that you don't have a crazy Friday into the weekend. You have a nice, relaxing day. So this is just an overview of what we talked about. I know we talked about a lot of things. But if there's one thing that I want you to take away from this, it's to shift the security focus earlier in the process. So some people call it shifting security left, but that's incident response. That's threat prevention. So it kind of wraps up a lot of what we're talking about. So if you want to get the code from my presentation, this is the QR code for that. So get out of the way so that you can scan that. And that's a repository with Next.js and app router. And it uses SST and CDK like I talked about. And yeah, that's me. But thank you again for taking the time to come to my talk. And I hope that this is empowering and helpful for you to architect security into your development journey and really put the dev in DevSecOps. So thanks for coming.